This video demonstrates the contact analysis. Here are two bodies. Both the bodies are made up of steel material. The parts are a rail and a wheel. They are having a point contact between them. And these two bodies are meshed with the suitable elements. The desired results like the stress and the contact pressure are evaluated. Let us proceed with the tutorial. Create an assembly in any CAD modeling software. Project the curves on the surfaces where the contact will be taken, which means around the contact interface, create some of the curves so as to define as the contact surfaces. In this case, you can observe that here are some of the curves highlighted in blue color for the cylindrical body, and here are the curves highlighted in blue color for the rail body. Once the modeling is done, export this part files to a neutral format like STEP so that it can be opened in ANSYS. File, save a copy as an IGES format or the step format. Currently choose step format and enter the name of the file as railway wheel. Ensure in which directory this particular file will be saved as a step format. Click on OK. Under the Export Step window, solids and shells are selected. Also select the datum curves which are required for splitting the surface in ANSYS Design Modeler. Click on OK. It can be observed in the command line that the file has been exported in the step format. Now, open the solver or the ANSYS project. Create a new static structural project. Rename the file as railway wheel. Enter. Under the engineering data, enter the material properties. Before that, check the unit of the whole project. Pick on units. Check it is a metric activated. Units are ton, millimeter and second, which are the desired units at this moment. Double-click on the engineering data to define the material. It can be observed that the structural steel is now selected, and these are the default properties of the structural steel. Now change the unit of these material properties. Density to be in ton per millimeter cube. Young's modulus to be in megapascal. And enter the value of Poisson's ratio. If at all bilinear kinematic hardening need to be included, means bilinear isotropic hardening need to be included, pick on the isotropic hardening here. which will be included in the properties here. Change the unit to MPa and change the tangent modulus unit also to MPa. Yield strength to be 250 MPa and tangent modulus to be 20,000. Once the material is completely defined with the proper units, return to the project. Now import the CAD geometry. Right click on the geometry, pick on Import Geometry. Browse for the particular file. That file is in the D drive and it is in the railway wheel. Under the railway wheel, pick on Railway Wheel STP. Pick on Open. You can observe here the check mark which highlights or which says the geometry is now imported. To edit the geometry, double click on this geometry. Observe the design modeler is now starting. In ANSYS Workbench, select the desired unit as millimeter. Pick on OK. Under the import options, we have to import the models, that is the solid bodies along with the line bodies. In this example, the surface bodies are not of importance. Pick on the line bodies as yes, so that all the line bodies will be imported which are used for splitting the surfaces. The symbol which here represents the model is not regenerated. Observe the symbol carefully. Now pick on Generate. The CAD geometry will be refreshed and imported. This model has too many bodies, including the lines, which can be seen from the parts of the bodies. Actually, we need only the roller and the rail. Others are the lines which were used to create the projection on the surfaces. At this moment, suppress the line bodies which are not required. This line body is not required. This body is not required. Similarly, this body is not required. Similarly, this are not required. Right click on them, pick on Suppress Body. Now go for the next body. This is the required body for splitting the surface. Similarly, this body which is not required. Suppress this body. Go further. This body is required. This body, this and this are not required. Suppress the bodies. Go further. This body is required and this body is required. Remaining bodies suppress. Now observe that you can find only the curves which are required for splitting the surface. Now pick on Tools, pick on Surface Split. Pick on the face to be split under Target Face as this face. Apply and Tool Geometry to be a curve. Ensure that curve is now selected here. Pick on this curve. Control, pick on this curve. For better picking, rotate the model and pick on the curve. Pick on Apply. Now observe the face split is now in the model tree. The symbol is the model is not regenerated. Pick on Generate, which means the surface have got splitted now. Now pick on the face split again, tools, face split, pick on this face to be split, pick on apply, the tool geometry to be an edge, pick on this curve and pick on this curve, apply. Now pick on generate. Once the surface have completely split, suppress the bodies or the line bodies which are not required. Right click, suppress. You can observe now we can find the split edges, not the curved bodies or the line bodies. It is the time to proceed with the simulation of these two bodies. Now come back to the project page. Under the model, right click, pick on edit. Observe the starting mechanical is now activated. Observe that the model is now imported into the solver. Here are the geometries, and here is a coordinate system, and here is the default connection which was identified automatically. The main objective of splitting the surface was to give only the area which surrounds the contact, which helps in reducing the number of contact elements, which means if the contact is defined between these whole two bodies, then the computation time will be more. This is the enough area required to define the contact or the interface. Now it is the time to mesh the model. Right click on the mesh, pick on update. Once the model is meshed, it is the time to define the proper contact. Pick on the contact region. It has taken the contact region between two bodies. The contacting bodies is the roller, which is highlighted in red color, and the target bodies is the rail, highlighted in blue color. Here it should be a frictional contact because there exists a friction when they are interfering or when the contact is interfacing. Enter the coefficient of friction between the steel bodies as 0.15. Scope method, keep it automatic. Pick on the behavior as symmetric behavior. Under the formulation, select the formulation as augmented Lagrange. Similarly, change the detection method as program controlled and interface treatment as add offset with the ramped effects, means the load will be applied gradually. These many parameters are defined or required to define a contact. Now right click on the contact connections here, insert, pick on the contact tool. Look for the initial information and right click, generate initial contact result. The contact information is now generated. and that can be seen by picking on the contact information. Both the contact and the target are highlighted in yellow color, and the status is open, and this may be acceptable. Now, define the necessary boundary conditions. Load. Pick on the static structure here, right click, insert, pick on the fixed support. The base of the rail is going to be fixed. Ensure that the face selection is active and pick on this face. Select apply. This face will not be translated any of the direction, or which will not be rotated in any of the direction. Right click on the structural analysis, insert the force. The force to be applied on this face in the negative y direction. Hence, define the force on the y component. The y component to be minus 100 Newton force. Confirm the geometry selection by picking on apply. Observe that the force is now created on the face. Now apply the constraints, that is the displacement constraint, which means this body is not at all constrained. To constrain this body, right click on the static structural, insert, pick on the displacement. Pick on this face and leave it to move in the y direction, but x and z direction to be 0. Ensure the geometry selection by picking on apply. Now the model is ready for the simulation. Pick on the results which need to be retrieved. Now right click on the solution, pick on the insert, pick on the stress, pick on the von Mises stress. Similarly, right click on this, insert the deformation, pick on the directional deformation, that is y directional deformation. Now the load need to be applied gradually, hence define the time stepping. Pick on the analysis settings. Under analysis settings, automatic time stepping need to be switched on. Enter the initial substeps as 20. Enter the minimum steps as 10. Enter the maximum steps as 50. So that the load will be divided into 20 equal number of parts. And the minimum steps will be 10. And the maximum limit is 50. Now right click on the solution, pick on solve. You can observe the solution status is in progress. Pick on the solution information and check for the convergence plot, that this particular problem is now completely converged. Pick on the equivalent stress and change the magnitude to be 1:1 scale. Now pick on the equivalent stress to know the magnitude of stress value and the deformation. To know the contact pressure, right click on the solution, insert, pick on the contact tool. Under the contact tool, right click, evaluate all the results. Contact status is now evaluated, and right click, Insert, pick on the contact pressure. Right click, evaluate all the results. This will show the contact pressure and the contact status. Contact status here represents the blue highlighted is the far contact, yellow represents the near, orange represents the sliding, and the dark orange represents that the bodies are sticking. Click on the contact pressure to know the magnitude of contact pressure. The results can be plotted in the different windows. Pick on Fit All in all the windows and view the results separately. In the first window, observe the geometry. Second window, observe the mesh. Third window, observe the equivalent stress. And fourth window, observe the contact pressure. For better visibility, hide these windows. Thank you for watching this video.